here is the system simulation that evaluates inventory levels for a given reorder point, with demand coming in at a random rate and lead times which resupply our items, our inventories, also subject to some random variation. We have an evaluation period of 220 days, or whatever units of time you want to consider. We also have a macro that we described earlier that allows us to evaluate the system's policy, the policy being the reorder point level, over those 200 days. Here I have a little button linked to a macro. Let's see if I right click on the button. Macro 1, that's the one that allows us to recalculate the sheet 200 times, or do the 200 period evaluation of the policy. If I click on that button for that particular policy, it's going to evaluate all 200 of those days and give a summary of what happened over that period. The summary measures include fraction out of stock, average held per period. These are two competing performance measures. As we increase the reorder point, we're going to be seeing higher levels of stock held on average. We're also going to be seeing smaller levels of fraction of out of stock, and vice versa. As we lower that reorder point, we'll see fraction out of stock go up, which is not something we want, but we will see the inventory held go down. So in order to get a composite of these performance measures, we can create something called an implied net cost by somehow merging the two factors together. What that mathematical combination may be, well, it could be additive, it could be something more complex. If I use an additive calculation to create a single overall performance measure, the nature of that performance measure is going to tend to be parabolic. So my big question is, well, what value of reorder point is going to get me to the bottom of that parabola, the lowest cost level of that parabola? And I could go in and I could change this policy so that I'm looking at different values manually and evaluating these policies manually, even with the assistance of this macro. I don't want to really do that because that's going to be taking a lot of time, and I want to avoid carpal tunnel syndrome. So what I'm going to be doing is allowing an engine like RiskOptimizer to do that work for me, to evaluate different order point policies, each over a 200 period time frame. To do that, let's go to RiskOptimizer. I'll go to the model definition. It's a pretty simple model. All I'm doing is minimizing that total net cost by changing the one policy decision that we're discussing, that is the reorder point level. So I'm trying to minimize what's in K36 right here, total net implied cost, and doing so by modifying what's here in C18, the reorder point level. I have bounded this, but I don't really have to. For demonstration purposes, it's easier for me to provide a somewhat limited range for examination. But if you don't know the bounds on your decision variable, you can make them as large as possible or not have them exist at all. In this case, it's again better for illustration purposes. I'm going to hit OK and just let the engine do its work by hitting start. Here's the progress bar. We've started out with a original performance level of 113.9. Remember, we're trying to get that as small as possible by getting RiskOptimizer to evaluate different reorder point levels. And that's exactly what it's doing right now. As it goes through what are called simulations, in its terminology, what it's really doing is modifying that reorder point level and evaluating the system over 200 iterations, 200 periods, which is our our baseline of total system evaluation. Remember, we chose 200 periods because looking at how the system has done after only a few might be very misleading. We'll go up to 160 and then stop. And I get the notice, so I want to stop the optimization. Yeah, I'm pretty sure I do. So I'm going to hit yes. And it gives me an additional option of seeing some of the statistics associated with the evaluations it's performed. It's evaluated, again, 160 or so. Incidentally, we give it a range of 40 to 120 reorder point levels, so that's really only 80 different levels. Why has it evaluated 160 different levels? Where do those other levels come from? Well, many of those are just repeats. We know that the performance of any one policy may differ based on the random numbers drawn, so it's good to reevaluate them. And the ones that are being reevaluated the most are the ones that come up as good the most. Remember, this is a genetic algorithm search mechanism, so those policies that do well, they get revisited more frequently. That tends to be the case, unless you have some other mechanisms in there. And I can request to re-examine what exactly has been going on during the search, a log of everything that RiskOptimizer saw along the way. It creates a new spreadsheet which lists all of the runs it's had, all 163 or so evaluations, and the composite performance it has seen for each of those evaluations. If I want to get a better impression of how that decision variable impacts my performance, I can create a graph, a scatter plot, and again, there is that prototypical parabola that we anticipated. As reorder point policies go up, the cost associated with holding inventory goes up, but as they go too far down below a certain level, the cost of being out of stock is kicking our total costs up again. So we want to be somewhere here at the bottom. The best policy that we found the end of the search process was, I believe, somewhere around 56.